continuation of the topic matrix. We want to see equality of matrix and transpose of matrix. So, we want to look into equality of two or more matrices. Equality of matrices. When do we say that two or more matrices are equal? One, if they have same order or dimension. Same order or dimension. Two, if their corresponding elements are equal. So, when two or more matrices have same order or dimension and their corresponding elements are equal, you say they are equal. Take for instance, if they say that this is matrix A, 2, 3, 4, 2, 5, 6, 1, matrix B, 2, 3, 4, 1, and matrix C equal to 2, 3, 4, 1. And they say which of these matrices you have here, which of them are equal. Now, this one, what is the order of it? All you do is I check their order first. What is the order of this matrix? The row is 1, 2. The column is 1, 2, 3. So this is the order of it, 2 by 3. What is the order of this matrix? 1, 2, 1, 2, 2 by 2. What is the order of this matrix? 1, 2, 1, 2, 2 by 2. Now, this one and this one and this one is not in the same order with this other two. Then you check these two that have same order. All you do now is that you say this one have first element to be 2, this one have first element to be 2, this one have next element to be 3, this one 3, this one 4, this one 4, this one 1, this one 1. So you conclude by telling them that matrix B is equal to matrix C because they have same order and their corresponding elements are equal. Please, if any of these elements is changed, if the position of any of these elements is changed, they are not going to be equal. It must be in the same order as you see it and in the same position. The elements must be in the same position before you say that they are equal. Then we come again and say, given that matrix P is equal to 2, given that matrix P is 1, 2, 3, 4, and matrix Q is equal to S, Y, Z, 2A. S, Y, K, 2A. And they say find S, Y, and A. Find S, Y, and K. If the two matrices are equal, I repeat again. Given matrix P equal to 1, 2, 3, 4, and matrix Q equal to S, Y, K, 2A. Find S, Y, A, and K, given that these two matrices are equal. All you do is that you remember, for two matrices to be equal, they must have same order and the corresponding elements are equal. You look, this and this are in the same order because this is 2 by 2, this is 2 by 2. So what you do is I say their elements must correspond. So 1 is correspond to S, you say S equal to 1. 2 must correspond to Y, you say Y equal to 2. 3 must correspond to K, you say K equal to 3. Then 4 must correspond to 2a. That means divide both sides by 2, we get the value of a to be 2. Therefore, a will be equal to 2. So he said that their answers, the answers for S, Y, K, and A are 1, 2, 3, and 4 respectively. So we've been able to see when or equality of matrices, or when we are to say that 2 or more matrices are said to be equal. Now, we have said that they are equal when they have same order or dimension and when their corresponding elements are equal. We want to go into transpose of matrix. How do we do transposition of matrix? For you to say you have transposed a given matrix, it means that you will interchange the rows and their column, such that the row will become the column. I repeat, transpose of any matrix simply means interchange the rows and the column of that matrix. Transpose of matrix. Transpose of a matrix. Given matrix A equal to A, B, C, D. A, B, C, D. Okay? Given matrix A to be A, B, C, D, E, F. Then they say find transpose of this matrix. Transpose of it written as AT equals to. Now, how many elements does it have? It has 1, 2, 3, 4, 5, 6 elements. Now, what is their order? The order is number of row 1, 2, and number of column 1, 2, 3. 2 by 3. This is the order of this matrix. Now, the implication is that what is the row? The row is A, B, C. The first row is A, B, C. That A, B, C, make it to be, this is the first row, call the first row the column. It will become A, B, C. This is a column. Then call the second row D, E, F, column, D, E, F. This is the transpose of this matrix. That is, carry the row, call each column, carry the row, call each column. You are done with that. What is the transpose? What is the order of the transpose of a matrix? That will be opposite of this. 1, 2, 3. 1, 2. 3 by 2. That tells us that if we are talking about transpose of a matrix, it means call the row the column and call the column the row. So if the order is 2 by 3, the order of the transpose will be opposite, 3 by 2. That also takes us to given matrix B equals to 2, 3, 4, 5. And they say get B transpose. B transpose means this is the first row. Call the first row the first column. The first row is 2 and minus 3. Convert it to what? Column. 2 and minus 3. The second row, 4 and 5. Convert it to column. 4 and what? 5. This is a transpose. Now, a shorter cut of answering transpose of 2 by 2 unit 2 by 2 matrix. This is 2 by 2 matrix. A shorter cut of answering the transpose of it means, if they say get the transpose of it, it simply means, remember this is your off diagonal element. Minus 3 and 4 are known to be off diagonal element. So when you interchange it, when you interchange the off diagonal element, you have transposed 2 by 2 matrix. Only 2 by 2 matrix that you do that way. When you interchange the off diagonal element, you have transposed it. Let's interchange. We have minus 3 will replace 4 and 4 will replace minus 3. Then we have 2 and what? 5. So this is transpose of 2 by 2 matrix. That is, interchange the off diagonal element. Interchange it. Once you interchange it, you get it. interchange the off diagonal elements, you get it. Or you do it the way we did this one by saying take the row, call it column. Take the row, call it column. You get it. Take the row, call it column. Take the row, call it column. 2 and minus 3 will be 2 and minus 3. 4 and 5 will be 4 and 5. That is transpose of matrix. Let's see more example of transpose of matrix. When you have maybe 2, 3, 0, 1 minus 1, 4, and 5, 6, 7. This is matrix K. And they say find the transpose of this matrix. K transpose, that is the transpose of the matrix. It means the first row 2, 3, 0 will become 2, 3, 0, the first column. The second row 1 minus 1, 4 will become 1 minus 1, 4. The third row 5, 6, 7 will become 5, 6, 7. So as it was horizontally, you convert it like that vertically. 5, 6, 7, 5, 6, 7. 1 minus 1, 4, 1 minus 1, 4. 2, 3, 0, 2, 3, 0. That is your answer. You know you are correct. Now, another thing we want to look into is these two terms. These two terms that they call symmetric and skew symmetric. Symmetric and skew symmetric of a matrix. A matrix is said to be symmetric if the transpose of the matrix is equal to the matrix itself. If the transpose of the matrix is equal to the matrix itself, you say it is symmetric. But if the transpose of the matrix is equal to negative of that matrix, you say to be skew symmetric. You call that, you say that that matrix is skew symmetric. Okay? Now take for instance, when they say matrix Z is equal to 0, 1, 1, 0. You know that Z transpose will be what? Transpose of this 2 by 2 matrix means interchange the what? Of diagonal element, or take the row, call it column. Our first row is 0, 1, you call 0, 1. First row, second row, 1, 0, you say 1, 0. Or you interchange the what? Of diagonal elements, you still have the same answer. I repeat, call the first row, the first column, call the first row, the first column, you have gotten your Z transpose. You can see that Z transpose is equal to the positive of the matrix. Z transpose is equal to the Z itself, matrix Z itself. So you say that Z is equal to Z transpose, so they are symmetric. But when do we talk about skew symmetric? Take example of a matrix that is said to be skew symmetric. When matrix R is equal to, when matrix R is 0 minus 1, 1, 0. What is R transpose? Transpose of matrix R is interchange the off diagonal element, or carry the first row, which is 0 and minus 1, write 0 and minus 1. Carry the second row, which is 1 and 0, write 1 and 0. Or you interchange the off diagonal element. Carry minus 1 right there, carry 1 right up, you have it. Because we say that is a shorter way of writing transpose of 2 by 2 matrix. Now, we have gotten the R transpose. What is negative R? Negative R simply means carry minus and multiply the matrix R itself. Carry minus and multiply matrix R itself. You say minus times 0, 0. Minus times minus 1, 1. Minus times minus, minus times 1, minus 1. Minus times 0, 0. I take it again. Minus times 0, 0. Because anything times 0 is 0. Minus times minus 1 is 1. Minus times 1 is minus 1. Minus times 0 is 0. Can you see that R transpose is equal to negative of R? So this is equal to this. You say that they are skew symmetric. We said that they are scale symmetric. That is about equality and transpose of matrix. Please keep in touch with the video because we'll learn more on this matrix. We are not stopping here. We are going to operations of matrix. What and what do we do in matrix? See the next video. Don't forget to subscribe to our YouTube channel, like our video, and keep in touch with us. See you in the next video.